This is a tutorial for decimals. Let's start. To express the fraction as decimal number, we have 3 over 4. So a fraction is also means a division. So this is 3 is divided by 4. So when 3 is divided by 4, we have this less than 1. So 0 0.7, we have a 2, so 5. So we can do it like this. 3 is divided by 4, 0 point, with the 0 here, 7, 2.8. 4 times 0 0.7 is 2.8. So there's something left. There's 0 0.2 left. So add a 0 here. Then this is 0 0.05. So 4 times 0 0.05 is 0 0.2. Okay. This is how to do the division. So 2 is divided by 5. This is 0 0.4. Okay. So similarly, okay. Number 3, 9 is divided by 10. This is 0 0.9. So it's like moving the decimal dots from here. It's like we have decimal dots here, although we don't show it because this is not a decimal number. So 9, and then we turn it to here, then we have 0 0.9. You can also do it the original way. 9 divided by 10 is less than 1. So 0 0.9 times 10 is 9. Okay. 4, 11 is divided by 8. So this is 1. We have 3 here. 3 is a 3. 3 times 8 is 24. Then we have a 6. 6, 7. And we have 4. This is a 5. Okay. And then, okay, I'll show as well. 2 by 8, 1. Always lines up the unit digits. This is 8. We have 3 left. So and then 6. We have 7 here. We have 56. And then finally a 4 here. So the last digit will be a 5 because 5 times 8 is 40. Okay. Be careful when addition goes long because the digits has to always line up. Okay. So 5. This is 2 and 5 is 6. So we only have to do the addition on the fraction side because it will be 2 point something. So 5 is 6. 7, no, 8. Because 6 times 8 is 48. So we have 8, we have 2, which we have 3, and 2 again. Oh, so it will be 2.83 of recurring. So 5 is 6. 0.8 we have a 2 here, then 3 for the 18, 2 again, so 3 for the 18, so we have 2 again, so we see this is recurring, so this is 2.83 recurring, or if in fraction, if we turn it to improper fraction, which means the denominator is larger than the denominator, then it's 6 times 2. 6 times 2 is 12. 12 plus 5 is 17. So this is also a 17 over 6. Number 6, 5 over 12. So how do you do this? So 5 over 12 is less than 1. 0.4 is 48. Or 4.8, because 0.4 times 12 is 4.8. So we have 2 here. Add a 0. This is a 1. We have 8 here. Add a 0. We have 5, 6 here. Yeah, we have 6 here. Oh, we have 8 again. So we have 6 again and then recurring. So this is 0.416 recurring. Okay. Or just use the fraction. Just use 5 over 12. Yeah. And express the decimal numbers as fraction. So now we turn this into fraction. 0.28. This is 82 over 100, and which means it's similar to this one. And we have both of them divisible by 2, so 41 over 50. Okay. Okay, it's bad like this. But then actually the shortcut is that it is like the denominator start at the decimal dots. So this is the 1, 0, 0, the denominator. Okay. 4.05. So this will be equals to 4 and the decimal part. So it's like putting up like this one. So 4 in the decimal part. So decimal part is 5 over 100. Again, decimal dot, the denominator 1, 0, 0 here, denominator. So we have 5 and 100 are both divisible by 5. So we have 1 over 20. And we have, so we turn into fraction such that they have a common denominator. So something over 12, 20 should be equal to 4, which means 80. Because 80 divided by 20 is 4, because this is 4. So we have 81 over 20. Number 9, 10.2. This is equals to 10 plus the decimal part turned into a fraction. So 2 over 10. Yeah, decimal dot is like position of 1 at the denominator, 0. Okay, that's why 10 is the denominator for 2. This is equals to and find the common denominator of 10. It's 102 over 10. And 8. Out of 10, 0.08. is equals to 8 over 800. Denominator will be 1, 0, 0. The 1 is at the decimal dots place. This is both of them are divisible by 4. 2 over 25. Number 11 is equals to 1 plus the decimal parts, 2 over 1000. 1000. This is the denominator. Okay. So we have 1 plus 1 over 500. This is 500 over 500. So 501 over 500. 12. 0.0206. This is 206 over 1. Again, for the denominator, the 1 line up with the decimal dot, and 0 for all the rest digits. Okay. Both of them are divisible by 2. 103 over 500. Okay. Okay, next let's do some evaluation. The 23.04 plus 0.19. So we line up the digits. 4 is the same digits as 9, and 1 is the same digits as 0 here. So 4 and 19 is a 23. So this is equals to 23 is from the 23 plus 0. Then 04, 0.04 plus 0.19 is 0.23. So 23 again. So we can do it like this. Always line up the unit digits, and the rest follows. 4 plus 9 is 13. With 1 here, 2, or just 4 plus 19 is 23. And 23. Okay. So this is 67.7. So we're adding this up. We have to add a dot 0 for the 0.7. So we have 7, 7, 6. Okay. So 0.03 is the 3 is the same digits as the 9 here. So this is 2.825. The 0.005 is not affected, and then we are adding. It's like adding 3 to 79. So let's do it like this: 2.795 plus 0.03. We add the 0 here, and 528.2. Okay. 0.5 minus 4.6. Okay. We'll get a negative number here. So negative 0.5 minus 4.6. So 5 minus 6, we have a 9 remaining, but then become negative. So we have 4 here, but I have to oh yeah, it's 9 here. So we have this 4 has to become 3, because 0.5 minus 0.6 is negative 0.1. negative 0.9, sorry. So yeah, 0.5 minus 0.6. No, is negative 0.1, yes. So then the 4.0 minus 0.1, we get 3.9. Okay. And then and the answer has to be in negative. So this is negative 3.9. It's 3.7 minus 1.2. This is equals to 2.5. Just doing this. This is 5. 12 minus 0.07. 0.007. So to like add the digits for the 12, shows that they can line up. So 0 minus 7 is 3. This become a 9. And then 0. Have 11 here. It is 11.03. With that, we also have the 9. Okay. So this is 3. And then become a 9. Oh, because this become a 9, so this become a 9 as well. Because so we look at it like this. This is like 1,000 minus 7. We should get 993. So if we use the like transfer digit thingy, we have to transfer 2 times here. However, if we look at this like 1,000 minus 7, then this is 993. And we borrowed the 1,000 from the 12. So this is 11. Okay. And 119, 5 times 0.6. This is a 3. So 5 times 0.6 and 0 for it. And oh, am I doing this? Just with fraction. So 5 times 6 over 10. 30 over 10 is 3. Maybe we can also do this. So this is a 3. Oh, this is decimal place. This is 3 here. Okay. So 20, 14 times 0.02. So this is equals to 14 times 2 over 100. Will be 28 over 100. And both of them are divisible by 4. 7 over 25. Yeah, that's just fraction. This one, the position of the digits for the answer is hard to line up. However, we can still do that because 6 times 5 is 30, and it is 0.6. So the result should be 1/10 for the 30. So this will be 3. As 3 as a unit digit, so 3.0. Number 11, number 21, 0.4 times 0.5. This will be 0.2. But it is like halving the 0.4. Or we'll use fraction. So 4 over 10 times 5 over 10. 20 over 100, which is 0.2. This is 2 over 10. And which means it's 1 over 5. So it doesn't specify what the answer should be in. So it can either be in decimal or fraction. 22, negative 9.2 times 0.3. So negative number times the positive number, the result should be negative. Then we do 9.2 times 0.3. Okay. So for this one, we can use the multiplication method. So 9 is like 92 times 3. So we have 6. 3 times 9 is 27. 276. Then we have 2 1/10 multiplied together. So we'll divide this by 1 over 100. So this will be, the little dot will be here. So what happened is that so we know it's negative. So that's just showing negative, and then we do 9.2 times 0.3. So for 9.2 times 0.3, we can use fraction. So we can use actually using decimals, multiplication will be easier here. So I just turn this into 92 times 3. I multiply both of them by 10. So which means to make the equal sign logical, I have to multiply to 1 over 10 as well. Because I multiplied 92 by 10. So it's like I multiply the whole thing by 10, and then by 1 over 10, by 1 over 10. So this is 1, this is 1. So I just multiply everything by 1, which means I didn't change anything if I do this from here to here. But in this way, I can do the multiplication in an easier way, because 92 times 3 is 6, 3 times 2 is 6, 3 times 9 is 27. I just got 276, and this is 1 over 100. So 276 divided by 100 will be 2.76, because the decimal dot of 276 is here. Then when we're multiplying by 1 over 100, we can do 1 times 2 times. Make it smaller by 2/4 of the log scale of the 10. We'll talk about what is log later, but for now we can do this. So yeah, then it becomes a negative 2.76. Although we can also use fraction in a way. But then, we're also using fraction here. So 23, 6 over 5 times 1.2. So whenever we see this, we either turn both of them into decimals or turn both of them into fraction. So let's turn both of them into decimals. So this is 6 over 5 is 1.2 times 1.2. This is equals to 12 times 12 is 144. Then I did this, so I do like a little dot here. This is like I turn into 12 times 12 times 1 over 10 times 1 over 10. These two are the same because of this. This is multiplied by 1. Something here. Okay. So expression stays the same. Then this is 144 times 1 over 100. They become 1.44. So the decimal dot is here. Then 1 times 2 times to make it smaller, because times 1 over 100 makes the number smaller. And then because there are 2 0, so I move it to the left by 1, 2. Actually 4. This is 4. So because 4 times 1.5 is 6. Or we can use fraction or decimals. So this is equals to 60 divided by 15. Because I multiplied both denominator and denominator by 10. So it's like 6 over 1.5 is equals to 60 over 15. Hence, times 1.5 is 15. Because 1.5 times 10, I can move the decimal dot to the right to make it bigger. I make it bigger because I'm multiplying by 10. It's supposed to be bigger. And so I'm going to move dot to the right because it is the power of 10. And the decimal dot is here. So after moving, so this is 15. So and 60 divided by 15 is 4. So 5, 4.2 divided by 8.4, 4.2 divided by 8.4, this is a half, because 2 times 4.2 is 8.4. Or we can multiply both the denominator and denominator by 10. Become 42 over 84. Then we can do it like normally. So both of them are divisible by 42. 1 over 2. Okay. So 3.8 is divided by 19 over 10. Okay. So we use fraction here. 3.8 is 38 over 10. Okay. So again, for the denominator, 1 is lying with decimal dots 0 here. Okay. So 3 is 30 over 10. So we have to add up together like this previously, just skipping more steps. So this is 38 over 10. And divide by 19 over 10. This is equals to 30 over 10 times 10 over 19. Oh, both of these 10 can be cancelled. 38 and 19 are both divisible by 2. So this is both of them divisible by 10 to become 1 and 1. Both divisible by 19, 2 and 1. What's left behind is the 2. Number 17. The negative number divided by negative number, we have a positive number as an answer. Okay. Then 7.7 is just remember that the answer is positive here. 7.7 is divided by negative, so we can use decimals. Negative 7.7 is divided by negative 11. So the negative sign is cancelled, and 7.7 over 11. So multiply both of them by 10. We have 77 over 110. Okay. What did do? It's just multiplying by 1. So because 10 over 10 is 1. And both of them are divisible by 11. So this is 7 over 10. Okay, and the answer is the positive. Okay, this is the tutorial for decimals. You can also look at the concept video, which there will be linked below, to understand more about decimals. So see you next video.